This conversation with the Australian Museum's CEO and Director, McKay AO, and Professor Kris Helgen, who recently joined the Australian Museum as Chief Scientist and Director of the Australian Museum Research Institute, or AMRI, was recorded during a live event for patrons to the Australian Museum Foundation. So firstly, the Australian Museum acknowledges the Gadigal people of the Eora Nation, the traditional custodians of the land the museum is situated on, and we pay our respects to elders past, present, and emerging. My name is Megan Warwick, the AMRI and External Partnerships Coordinator, and I'm the moderator for this session. At the end of this conversation, there will be a 10-minute Q&A session followed by a short poll. McKay AO, the AM's first woman director, has led the transformation of the Australian Museum into one of the world's preeminent natural history and cultural institutions. Since her appointment as director and CEO in 2014, her initiatives have included free general admission for children, the Australian Museum Centre for Citizen Science, the restoration of the Long Gallery, Australia's oldest museum gallery, as well as building new award-winning accessible entrance Crystal Hall. She is currently overseeing the AM's $57 million renovation, Project Discover. Next, we have Professor Christopher M. Helgen. Professor Kris Helgen joined the Australian Museum Research Institute, or AMRI, Director and Chief Scientist in June 2020. As Director and Chief Scientist, Professor Helgen is responsible for the AMRI team of more than 80 staff, including research scientists, collection officers, and more than 100 associates, fellows, and students who research and explore today's major challenges. Kris was most recently Professor of Biological Sciences at the University of Adelaide. He has focused his research primarily on fieldwork with living animals and research in museum collections to document the richness of life, explore global change, and contribute to important problems in biomedicine. Donors to the Australian Museum Foundation support a number of key initiatives, including research conducted by AMRI scientists. We hope that you enjoyed this conversation, which commenced when Kim and Kris asked about his passion for mammals and what mammals can teach us.
I like to explain, and this is really very true, I learned the technical language of mammalogy, including the Latin names of all mammals on our planet, as a kid, almost like you would learn and absorb a second or third language. And so that is it. So as if I spoke English and Spanish, when I speak about mammalogy or hear the Latin name of an animal, there's no question that I'll know exactly what it is.
So you speak mammal.
I speak mammal.
Which is extraordinary to think that you did that. Did you set out to do that, or did it just come as natural?
It just emerged through my childhood and my growing up as a teenager as just something that was such an overriding passion, and I had to kind of know that answer and how many were there. Can I figure all of them out? And that gave me this platform at a very early age that when I would be able to meet and introduce myself to professionals in the field, they instantly saw that I had that grounding. I went later to Harvard as an undergraduate, and one of the reasons I wanted to go there, I read Ed Wilson's book, Naturalist, as a kid, and I read it and I said, he talks about working at the Museum of Comparative Zoology.
Yeah.
I said, what could be better than a Museum of Comparative Zoology? I went there, and what I was able to do there as a scientist, as a young, growing, maturing scientist, was take that language of mammalogy, the technical terms about teeth and bones and scientific names, and map that in my brain to all the anatomies that I could see. And that's what I've done ever since. So if you show me a skull of a mammal, I'll pretty much know what it is right away. And that also is part of the way I work. I'll also pretty much know right away if it's something that isn't in the books, isn't on the charts.
Wow.
Yeah.
Wow. So when you went to Harvard as an undergraduate, you met Tim Flannery there, didn't you?
Yeah, I did. I actually, this is one of the great stories of my life. I was able to, I had some funding to go to from Harvard for a summer visit to Australia for a few weeks.
Mm.
I was 18 years old. And when I came to Sydney, the first thing I did was make a beeline for the Australian Museum. So I went in on the old William Street staff entrance, and I went up to the receptionist there. This is in the late 90s. And I said, I'm just a kid. I said, is Tim Flannery here? Could I talk to him? And she looks at me and she says, well, is he expecting you? Of course, I just walked in off the street, and I said, well, I don't think so. But, and she said, well, let me check. And she picks up the phone, makes a call, and she says, well, Tim Flannery's coming right now. He comes out, didn't know me from Adam. We say a few words. He grabs me by the arm, pulls me behind the scenes, takes me into the mammal collection, and within 90 seconds, we're pulling open drawers, and he's showing me tree kangaroos that he gave the scientific name to. And I had seen Tim in things like National Geographic magazine and read some of his articles growing up, and this was an incredible moment. But there's this particular moment where he pulled out, we have in this museum this special drawer of extinct Australian animals.
We sure do.
It's an incredible thing. Well, that was the first time I ever saw it. He opened that drawer, and in the back of that drawer, there's a little beat up, tiny little kangaroo-like animal. Comes out of the central deserts, and all I did was see that beat up skin, and I said, Tim, is that Calopymnus campestris? This is an obscure extinct bettong known by very few specimens. And he looks at me, I'm an 18-year-old kid, and he turns his head, he says, yeah, that is Calopymnus campestris. So we were speaking the same language, and we have been thick as thieves ever since that moment.
Well, I don't think you could have had a better mentor in mammals than Tim Flannery at that time.
Absolutely, incredible.
Now, one of the things, I guess, probably that you learned from Tim is the opportunity to go on field expeditions to find new mammals. And you have led well over 100, would that be fair to say?
Well, expeditions, serious big operations, many dozens.
Many dozens,
At least 30 big operations, yeah.
Okay, so but you've named about 100 species of mammals.
About 100 mammals that I've, whether it's working in museum collections or leading field expeditions, getting out into some of the most remote, least known natural parts of our world, I've uncovered about 100 that are new to science.
So in fact, at your job interview here, you had us all engrossed in a story about one of those expeditions in South America. Could you relay that?
No, absolutely. It's absolutely one of the great moments in my life as a scientist. So I was in my early 20s. I was I was in Australia at the time. I was doing my PhD at the University of Adelaide with Tim. I met and fell in love with an Australian girl at the University of Adelaide from the Flinders Ranges. And I just said, Christmas time came. I said I'd have to bring her back to meet the family. Yeah. We flew back to Minneapolis, and we were there between Thanksgiving and Christmas, which is a long time to stay with the family. So we said we're gonna get out of the house for a while. So we drove down to Chicago.
It's also very cold.
It's very cold. It's very cold, but I like the cold. Anyway, we drove down to Chicago, going to visit the Field Museum, and they gave me the keys to the place, said go for it. And I was working through the night. Lauren was helping me, and I pulled open this drawer, big, heavy metal drawer in this case, and it stopped me in my tracks. It was one of these moments where I was looking at something that was so different from anything I'd seen before, and anything that it could be, my brain could instantly rule out. There were these fluffy red panda-like skins in this drawer, and they were supposed to be kinkajous or olingos. They were mislabeled, and I said, whoa, I've never seen this mammal before in a museum, in a picture, anywhere. And I opened up the box that had the skull of this animal, and I pulled it up, and I said, wow, the shape of the cusps on the molars was like no other mammal. The way the ear bones were arranged was like no other mammal. I said, could this be, a species of carnivore? This is the group of dogs and bears and cats and raccoons. This is the group that's about as well studied as anything. Could this be a carnivore that all zoologists have overlooked that has landed in this drawer? Well, as a detective, I worked it through. I studied the anatomy closely. I looked in every other museum in the world that might have specimens. I studied the fur. I studied the bones. We studied the DNA. And sure enough, this thing was completely different kind of raccoon-like carnivore mammal. And so, we could have stopped it there. I said, we could have named it and announced it, but that's not my style. So my style is to get into the wild, to get into remote areas and see what we can find. What does this animal do for a living? If it was there, and by the way, these specimens were 60, 70 years old, overlooked that length of time in the museum. I looked on the map. The place where they had come from, which was on the border of Colombia and Ecuador, get on Google Earth, look around, the whole thing has been deforested. It's agriculture, it's coca plantations. I said, we're going to go to Ecuador, just across the border where there's some good forest, and we're going to see if we can find this animal. A bit of a needle in a haystack. We went down there, flew down. We took a bus, we took cars, we took four-wheel drive, we got onto mules, and then we walked finally all the way up into this pristine cloud forest. Are we going to find this thing? The very first night we found this animal that turned out, we ended up calling it the Olinguito. Incredible to see. The pictures are going to roll through at the end again. You're going to see this animal, the Olinguito. It is an adorable creature. When I went on to announce it to the world, we had a press conference at the Smithsonian. We had something like 100 outlets, and it was on the front page of many, if not most, of the big papers in the world. It was on the front page of the Washington Post when I rode the subway into the museum that morning. It was fantastic.
What a thrill.
It was a thrill.
But it's a thrill to announce it, but I think what I really like here at the museum is when you learn about that moment of discovery and share it with your colleagues. I mean, you and I had an extraordinary experience today with one of the AMRI team who announced his amazing finds, which were actually funded by the Australian Museum Foundation. I can't go into it now, but suffice it to say it was Matt McKay, our paleontologist, and his discoveries are remarkable and will be world-changing in paleontology too for their impact.
It was an oh wow moment today. So I had heard whispers about this discovery. Today we got to see it fleshed out just internally. It's not ready to go out to the wider world yet, but everyone will hear about it before long. But this is not just a fossil discovery that changes our thinking on this way or that. This is something that is transformative. And seriously, sitting through that seminar today and being blown away, it made me think, okay, I have made the right decision to come here. I am in the right place being the director of science here at this museum.
Well, so let's talk about that, because obviously, as I said at the start, this is an opportunity at this time where we've rebuilt the physical amenity of the museum, but it's an opportunity for us to reset some functions, and we plan to do that in areas like climate change. But what is your vision for what you want to do here?
Well, what I really started doing as a Smithsonian scientist when I sank my teeth into museums, over the last 10, 15 years, what I started doing is I was really good already at this kind of work I'm talking about, documenting mammals, going on field expeditions. That work we do basically in inventorying the richness of life on Earth. How many kinds of mammals are there? We're good at that. And we're good at that whether we're talking about moths or mollusks or mammals, whatever it is. That's what we do here at the museum. But I started asking, that is amazing, and that is what we always, that has to always be a core strength. But is there more? Is there more? This is such an incredible resource. There is no other kind of institution in the world where you can walk in a big city into a big museum, go behind the scenes, and basically see a huge slice across the entirety of life. I'm talking about, you can see, in any really big natural history museum like this one, just this great accounting of, a huge fraction of all life on Earth into one place. Okay, and it makes you wonder, well, what else can we do? And so I started thinking, well, one of the things that we can do that no one else can do is be this incredible time machine. And I'm not just talking about the fact that we have fossils here and can study them, although that's always been important, and that is one way in which we're a time machine. It's also the fact that museums like this one, their collections have been built over not just decades, but centuries. And so if we want to know, what Sydney looked like, what Hyde Park looked like in the year 1820 or 1840 or 1860, 1880, you name it, it's really hard to reconstruct that. But there is only one place you can actually go, and you can go into a museum like this and find in the cabinets specimens that are labeled, Sydney, various parks, and you can start to study them. You can get DNA out of them. You can, take a little pick and clean out under the nails and pull out dirt, and that dirt that's sitting under the claw of that specimen is, a soil sample of the ground, taken out of that. So what I have started to do as a scientist is try to pioneer projects that let us do just that. Take a time capsule, whether it's that soil sample, that DNA, that summed up expedition of material that came from a particular place, and use that to paint a picture of what the world was like at certain points. And that turns out to be almost the best tool we have in the modern era for understanding across the last 100, 200 years, how has our world changed? We know climates are changing. We know habitats are shifting and changing. We know that this is a human-influenced planet on every single piece of it. But actually getting down to the nitty-gritty as a scientist and saying, we know it's changed. How has it changed? That's where we go. That's where we go.
Which is incredibly important. We live in the age of the Anthropocene now.
Right.
And we need to understand, hear more about it, and communicate more about it. So I know a passion of yours, as it is mine, is to try and make science very accessible and understandable to the public, the science we do here. And probably, I was going to use the example of there is no more relevant, given today's circumstances, issue than the impact of COVID-19 and the pandemic that swept the world. And you see an opportunity here for the museum to communicate more about zoonotic diseases.
I absolutely do. So, I mean, yeah, pandemic disease, like climate change, like, the loss of natural habitats. This is one of the big issues of our time. One of these grand challenges that's both medical and social, but also completely also environmental, right? So these big issues of our time, and we've just named some, again, climate change, biodiversity loss, disease. All of these things are issues that sit at the interface between human society, economy, the social world of humanity, and the natural world. And pandemics, that's exactly what's happening, is we have, fraying habitats, declining biodiversity, expanding human populations, and that's where things come together. That aspect of a time machine, again, how can we understand how the world has changed? We can study disease in phenomenally interesting ways. We can ask questions like, which disease is which disease, let's say, which disease is associated with which flea or tick or mite or host animal, and which of those, which mouse does each flea and tick and louse sit on? Those are things that seem simple, but these become, unbelievably complex puzzles to piece together.
And of course, it's not the first time this museum has been involved in identifying the flea linked to a major disease at the time.
No, exactly. We've got a history here, like many big museums do. So I've told you about the Second World War. We had something called the U.S. and Australia Typhus Commission. Allied service people were dying in great numbers, both from disease as well as from actual combat and warfare. And what happened is initiatives were sent out to places like the north coast of New Guinea to try to figure out some disease like typhus, which exact species of mite is carrying it. How do you figure that out? You have to sample and do this kind of biodiversity work. And which mouse does it live on? One thing that isn't often realized is that a huge backbone of funding for many of the largest museums through the last century, especially, has been through public health initiatives that are interested in these questions. Where does disease come from, and where does it sit in nature? What do these viruses do for a living? When they're not in people. This coronavirus that we're looking at right now. 6 months ago, this lived in an as yet unidentified species of bat, but it lived in some species of bat that lives in China. And 6 months later, a virus that lived in a bat, probably nowhere else, that the world had never seen before, the human world, has completely transformed the entire globe. It wasn't the first time, it won't be the last. But the British Museum of Natural History, the Natural History Museum in London, it was work there on specimens of fleas that actually solved the age-old question of which flea is it that carries the bubonic plague, Black Death. Now, which flea is it? There are thousands of species of fleas that answered that question. At the Smithsonian, where I used to work, apart from Ebola, the other really scary viral disease in Africa of the last half century has been Lassa fever. And we still don't know where Ebola lives. It was work at the Smithsonian with our mammal collection and our that actually helped to understand that Lassa fever, when it's not jumping into people, lives in one species of rodent and that species only. Once you figure that out, that disease isn't as scary. You know where it is, what it does for a living, which animal it's in, which habitat, and you can take steps to control that, to mitigate the risk.
So what you're saying is the Australian Museum can literally leverage the asset of its collection to help solve some of these major health issues that have come to the fore. I mean,
that's exactly right. It is that resource, that collection, just in those ways I've described as sort of being a scientific disease detective, that might be completely unexpected to people listening, that we would have, in the cabinets of different kinds of animals or different species of fleas or insects, that we would actually have some of those answers buried that we can unlock here. So I'd love to see us doing more of that. How has the world been changing? How has species been declining? Distributions changing, parasites and pathogens shifting as natural habitats change. All of those are questions that are open to us because of the collections we have.
And of course, one of the things, because of your 11 years, I think, at the Smithsonian, and now your predecessor, Dr. Rebecca Johnson, is chief scientist there, which is remarkable. And I know you've worked with Rebecca over many years.
Yeah.
There's that opportunity for greater collaboration even.
No, absolutely. And a really kind of one of those funny things in life, we sort of swapped places.
Yeah.
She used to visit me at my office there, and I her. So no, we have worked together a lot. Love Rebecca, and of course, it's just a natural fit to continue working between big museums, Smithsonian, Australian Museum. We're gonna be doing lots of things together.
Well, that's great. Now, I know in those 11 years at the Smithsonian, you had many career highlights.
Yeah.
I know you had to work at some points with the President, Barack Obama.
Yeah, imagine that. It was an incredible aspect of being a young scientist there. So, we'd have interactions with all comers. You're part of the federal government working for the Smithsonian. So I was a federal government scientist. So, if any, I'm sort of the national mammalogist in charge of this big, incredible global collection, including all of the core North American biodiversity collections. Anyways, members of Congress would come. Supreme Court justices would come. I remember briefing Sandra Day O'Connor on questions about environmental decline in the Midwest and prairies being overtaken in that history. But the absolute highlight was meeting the Obama family.
Yeah.
And at one point before the family went on one of their several major tours to Africa, Michelle Obama came over in particular, and I talked to her for an hour about questions about nature and environment in Africa. And once we hosted one of the Obama's daughter's birthday in the Mammal Hall.
Oh, that's pretty cool.
That was pretty cool. That was great.
And I know you named a species of bat after Sir David Attenborough.
Another absolute highlight. It was Tim Flannery that first introduced me to Sir David. They're good friends, and that has bolstered a relationship that's been very important to me. I go to the UK quite a bit to work in the Natural History Museum, and I've even had the chance to sit down at an invite for dinner at his home. Incredible stuff.
He is an amazing man, and he came here, of course, for our 190th anniversary.
Yes, right, I heard about that.
And we gave him a special award, and we named a species of snail, well, actually a semi-slug after him.
Okay.
But it was a remarkable day because he talked about this museum and its significance, not just to Australia, but to the region and to the world.
Yeah.
That it was this institution that was set up to record everything in our continent. And that is the way he expressed it, was the day I went, the penny really dropped for me about the historic significance and that richness of our collection. That hopefully under your leadership in AMRI, we can really connect more with the public on in the future, I think.
No, absolutely, I think so.
Well, Kris, I'm thrilled to work with you. I'm having fun so far.
So,
yeah, we're having some really great discussions, as you can imagine. about the future of the museum and the opportunities in science here. And it's great to have a different perspective on our leadership team as well. So we're just really thrilled and delighted that you have joined the museum at this time and providing your experience and insights too. And there's a long way to go ahead. We've got great opportunities in front of us right now. And I just am thrilled at the prospect of working with you, as I'm sure all of you are, to get to meet Kris and hear some of his stories. Just before we take questions from everyone who's joined us today, there is one thing about you that I find particularly quirky.
What is
You
that?
said at the beginning that when you first stepped into a museum, you were fascinated by the museum shop, not because of the toys and things that were in there, but because of the technical books that he could find there.
Right.
Now, you happen to own over 12,000 volumes of natural history books, don't you?
I do. It is one of the central weaknesses of my personality.
I mean, that must be one of the
bibliophilic draw. Yes.
it must be one of the largest private collections, is it not?
Yeah, it's by all means the largest mammalogical collection in this part of the world. Yes.
And how does your wife feel about that now you've moved up? You had to transport it up from Adelaide, right? Where have you put it?
Yeah, well, it is in storage at the moment as we figure out. We're looking for schools. We're looking for where we're going to be living, and only once all these other pieces come together can I call in the shipping containers and the trucks and say, put them here. We're gonna.
How many shipping containers does 12,000 volumes?
I thought
fill?
that we'd get away with 2, and I had to hire a 3rd.
Okay. All right. So when
I love books.
I love books too, but I don't have 3 shipping containers full of them. But what I'm sure probably shocks people even more is I think you've read them all too. So
they're not usually the page turners, but I know what's in every single one of them.
That's right. So with that, I know some of you may have questions out there, and I'll throw back to Megan, who is moderating this session. She may have some of those questions coming through on Zoom chat.
Yes, thank you so much, Kim. Thank you both for such a fascinating interview. We do have a couple of questions that have come through, so I thought I'd just jump in. So one of those questions is, how does Australia compare with other countries with regards to animal conservation?
Yeah, great question. I mean, obviously one of the incredible parts about Australia in terms of its global standing is that its deep history of isolation has given it a world, a biota, of plants and animals that is just not like nothing else on the planet. That's one of the draws for me. Why did I leave the United States in the first place and come to work in Australia and New Guinea and the universe around? It is because of that global uniqueness. Every continent has a fauna all to its own, but none of them are so different from the others as the Australian continent. Now, you ask about conservation, and that's a tough one because this country, which is a country that I deeply love, has the worst track record of, in many measures, of environmental conservation of any country in the world, any country. So, developed or developing, it's extraordinary. We've lost since European arrival more than 20 species of Australian mammals, and that's to global extinction. We don't think they live anywhere in the world, and some of those were things that you could find in every state and territory in Australia when Europeans first arrived. So it's been an incredible decline. When you think about things that have become globally extinct, I'm thinking about mammals here, as well as those that have declined so much that they're just in a certain protected area or an offshore island or a zoo. That takes you arguably to something like a 6th or maybe even approaching a 5th of all the mammals of Australia. That is an extraordinary thing. That's something like a 5th of a continental fauna has evaporated in 200 years. So it's not a good track record. And the challenge is there to stem that decline. To say Australia has this history and that is not something that's been stemmed. It's not something that's stopped. But what's needed, if we're going to be serious about it, is say we're one of the world's great and richest countries, and we are the one that is most unique, arguably of any, in terms of the biology of the animals and plants we have. going to take it seriously. We're going to invest the money that it takes. We're going to develop the legislation that it takes. And that's still in front of us here in Australia. That's still things that need to be done.
Well, indeed, there are a lot of suggestions at the moment that we skirt our planning and conservation laws. Environmental groups I know have spoken up avidly over the last few days and very loudly about this issue, and it's not the time that we should be doing that, is it?
No, it's not. And anyways, we can do better. I mean, something like the United States, where I come from, has seen such environmental devastation over time. We think about, I was just talking about the loss of the prairies, imagine the decline of the bison and the passenger pigeon. Same time, in that same period of time, the last 200-300 years, it's actually hard to find a mammal that's become completely extinct. There's 2 or 3 that are arguable. And so, contrast that against 20%. You have some difference there. And a part of that has to do with legacies of conservation, investment, and legislation. So there are other models to look at.
Absolutely. Megan.
So we just have time for maybe one quick question as well. So this one is a bit more technical. So what is the importance of microbiome rewilding? I'm sorry if I didn't pronounce that correctly. And what's the importance of repopulating animals in their natural habitat rather than making them adapt to a new environment and new food sources?
Yeah, I love the question. It's creative. So the first part of that question is, what's the importance of microbiomes in rewilding? So for everyone here listening along, a microbiome is the sum total of microbial organisms that live on us. Now, you've all read that, here we are walking around as mammals, but the majority of cells that make up us as an individual are not human, they're not mammal, they're actually things like bacteria, especially bacteria, fungi, other kinds of microbes. And so that's true of any organism on the planet. And of course, there's only been the technology, which is mostly DNA technology for the last few years, that's really allowed us to understand the full extent of that. So what does it mean, Kim, that you or me are mostly microbes? It means that so much of what we do biologically has very little to do with our own DNA. Much of it doesn't. It has to do with the DNA of organisms in us. So whether you were a thylacine or a red kangaroo or anything else, you have in that same way your own co-evolved set of microbes, thousands of different species, billions of different cells that help you do what you do. Digest your food, keep you antibiotically clean over most of the surface of your body. Now, we know so little about this. We know it's important. But when we think about conservation, species that's almost become extinct, maybe we've saved it in a zoo or an offshore island. What we need to know more about is how has that microbial complement, that whole microbiome changed? How does it affect the health of the animal? Are they more in danger of extinction if we've scrubbed them clean and they don't have those microbes that they've had? We talk about sometimes bringing back something like the thylacine. That always comes back and back again. Are we going to be able to do that? Even if, and we can't do that, but even if we could do that, you would bring back a thylacine with a thylacine's DNA, and you would be missing almost the grand majority of cells that lived on a thylacine that allowed it to do what it did. You're missing that. It's gone forever. So microbiomes are fundamentally important. We need to know more about them, and we can do some of that work at the museum. I'll close by saying that we are really good at what we do, storing things in collections I call it we're in the forever business. Museums put things in archives and in collections, and we can always use them. But we also need to think, with each generation of us that come to the museum, what are the right samples to be putting in that archive? So more and more, we're going to think more creatively and not just put a skin and a skull or a fluid specimen in the museum. We're going to think about how can we capture that whole essence of the animal, and that's going to be important.
Great, Kris. Well, as you can see, everyone, we have a brilliant challenge in front of us with a brilliant new contributor to the team here and somebody to lead our scientists in the foreseeable future. I think 2020 is going to be a significant turning point for the museum. Just to give you a quick update on that, on Project Discover, we're nearing completion. We have about 3 more months or so building work to take place, and we will be open in the spring, which is incredibly important. We've been sort of fortunate that we've been closed by choice during the COVID-19 pandemic.
Really.
A bit serendipitous, but once we reopen, I think the public are really going to love what they see here. We're opening up so much of the museum to these new spaces, and we've been very fortunate already. A number of our donors have significantly supported some of those spaces for the creation of different areas for the future. So I'm really looking forward to welcoming all of you back in, and just want to say again, thank you so much for joining us this evening and for meeting Professor Kris Helgen. And you can see, well, we're close to the public still, and to our family, our museum family, the work of the museum continues day in, day out. So look forward to catching up with you soon. And thank you to all the team who staged this, from our wonderful development team. And just a little reminder in there that we're coming up towards the end of the financial year. A good time to ask for a tax deduction. And of course, we are fully tax deductible with donations, and the Australian Museum Foundation would really love to have your support. So again, thank you to the whole team in development, and our technical team who've done so well, and to Megan for helping us this evening. And we'll see you very soon.